Tēnā koutou katoa. Nau mai haere mai, hei Aotearoa Food Safety Science and Research Centre. My name's Tim Harwood. On behalf of the New Zealand Food Safety Science and Research Centre, I'd like to welcome you all today and thank you for joining us for this Food Science Seminar Spotlight on recycled packaging, descriptions, challenges and solutions. We're delighted to have Phil Bremer from the Department of Food Science at the University of Otago, explaining why it's important for each recycled packaging application that food companies and recycled packaging manufacturers work together to develop a shared understanding of potential food safety and quality risks, and to subsequently use this information to design appropriate safety and QA programs. So I'm sure many of you know Phil. He's a professor at the University of Otago, Department of Food Science, where he lectures on product development, food microbiology, risk assessment and food safety. Phil's research interests include the tracking and controlling of foodborne pathogens, investigating the role of microorganisms in flavour development, developing technologies and approaches to reduce food waste and exploring consumer knowledge and perceptions of a range of food-related topics. Phil's the Chief Scientist of the Food Safety Centre, recently moved into that role and also President of NZFSSRC. As I say, many of you will know Phil. So welcome, Phil. If you could load your talk, that would be great. And just to explain the format today, Phil's going to give his presentation. There's the ability to submit questions through the talk, through the chat function. At the end of the talk, we'll have some time for a bit of a Q&A session. So welcome, Phil. We look forward to your presentation.
Thank you very much. Tim, can you please confirm that you're seeing the correct screen?
Yes, that's great. Go for it.
Thank you. Tēnā koutou katoa, Phil Bremer, tā koroa. And my computer's just gone to sleep on me, so I'll just wake it up again. Okay, great to be here this morning. So of course, you all know the importance of packaging, the roles that it plays to maintain food safety and quality, minimise food waste, and of course, it enables New Zealand food companies to transport their foods all around the world. I'm sure you're also aware of the challenges associated with packaging, and particularly the perception that it is bad for the planet and that we need to do something about it. So in the response to these concerns expressed by consumers, advocacy groups and governmental agencies, New Zealand and many other countries have set ambitious goals to reduce the economic and environmental costs associated with food packaging. And many countries have indeed set goals or targets for the adoption of recycled packaging. While specific targets have not been introduced in New Zealand, there's interest to reflect on some of the points that came out of the Rethinking Plastics in Aotearoa report put out by the Office of the Prime Minister's Chief Science Advisor in December 2019. I've highlighted the main points in red on the next two slides. The first is that we need to have a system that is based on evidence, and evidence to support a lot of the decisions around the use of plastics in Aotearoa is lacking. However, irrespective of this, there is still desire or drive to uptake best practice use for plastics in New Zealand. And screen's gone sleep again. And the New Zealand government is keen to adopt a circular economy. In order to do this, this includes incentives to increase the use of recycled plastic to strengthen markets for recycled plastic in New Zealand. It also requires the facility to carry out life cycle assessments in order to make decisions and to develop support tools to make realistic science-based decisions. When it talks about thinking about the environmental and health implications of plastic, the report identified that there was a knowledge gap and that research agendas need to be developed, especially in relation to hazards. And these were regarding the environmental impact and the food safety of recycled plastics and new materials. In other parts of the world, guidelines have been more, and targets have been more firmly established. For example, the Australian Packaging Covenant Organisation has set 4 targets around packaging, And the one that's highlighted in red is that they want 50% of average recycled content included in packaging by 2025. In the EU, the position on recycled plastics is a little bit confusing, what's confusing to me, and some of the goals and regulations set by different agencies seem not to be that closely coordinated, but relative regulations and goals include Directive 94/62, where they want to have 50% of plastic waste recycled by 2025 and 55% of the plastic waste recycled by 2030. The important thing about this directive is that this directive will only be achievable if there is a significant increase in the recycled component of food contact materials, i.e. in order to use this material, they've got to put it somewhere, and that will probably go into materials that are used for food contact. There's also another strategy on plastics. This was released in June 2019. This is where they're talking about the increase of recycled plastics in all applications, including for food contact materials. And there's calls for PET bottles to contain a minimum of 25% recycled PET by 2025, and all beverage bottles to contain a minimum of 30% recycled PET by 2030. So there are significant drivers for the use of recycled packaging. So this research was undertaken owing to the fact that several companies within New Zealand expressed concern that substances in recycled packaging had the potential to migrate from the packaging into the food and cause adverse health impacts, and also adverse impacts on the product's quality, shelf life, and value. This research was funded through the New Zealand Food Safety Science and Research Centre. It had 6 industry funders and matching funding from NBIE. The research approach that we employed was we carried out interviews with stakeholders. These stakeholders included the food industry, and we asked them what their current and future demand for recycled packaging was likely to be. We also asked them about their perceived concerns around packaging and the opportunities they saw for recycled packaging. We spoke to recyclers, packaging manufacturers and suppliers, asked them about their current and future capacity to supply recycled packaging, and then also asked them what sort of safety and quality assurance processes they have in place. We also went out and talked to government and industry bodies and asked them about their current and future concerns around the use of recycled packaging. We then reviewed the scientific literature. We looked at the substances that may be present in recycled packaging and their potential to migrate from the packaging into the food and their toxicity, and then wrote some reports on the potential impact on human health and the potential impact on product quality and shelf life. And finally, we produced some guidelines for the use of recycled packaging in New Zealand. We had quite a diverse range of goals, and therefore we needed a diverse range of expertise on our team. This project was led by myself, but I had the help of a social scientist, namely Associate Professor Miranda Morosa from the University of Otago. We had a number of chemists and engineers involved, namely Professor Paul Kilmartin, Professor Brent Young, and Dr. Alice Itzabide from the University of Auckland. And there were food scientists involved, and this was led by Associate Professor Pat Silcock from the University of Otago. Before I get into our findings, I'd like to just give you a quick overview on the recycling of packaging material. So what's involved? In the first stages, there's the sourcing and collection of material. This material can come from 2 primary sources. Post-consumer, this is sort of the standard curbside collection that you're familiar with, where you put your bottles and plastics out, and then it's picked up and sent off to a recycling centre where it's sorted. The challenge with this post-consumer material is that it's poorly defined. It can contain a wide variety of different plastic types, cardboard types, etc. And of course, the containers could have been used for a wide variety of different uses. The other main source of material is post-industrial. This is from the industry, and this could be that a company is making a particular product, it's bagged or packaged for a period of time, and then it's taken out of those bags and used for a secondary product. And of course, that packaging material is well defined, its use has been well characterized, and it's ideal for being used in recycle applications. Regardless of the source, it then goes to a centre where it's separated into various grades based on criteria such as its previous use. Was it food grade or non-food grade, the polymer type, and for cardboard, it can also be graded based on the type of board. In terms of recycling of plastic, there's two processes that can be carried out. The first is mechanical recycling. This is where the plastic is cleaned using high pressure and high temperatures. It's then ground up, remelted, and regranulated. The application of the pressure and temperature is important to remove the contaminants that may be present on the plastic. However, this heat can break the intermolecular bonds within the polymers, lower their molecular weight, which can then lead to changes in the mechanical and optical properties of the plastic that is subsequently made out of the polymer. The other way in which plastic can be recycled is via chemical recycling, and this relies on the fact that the polymers can be broken down to the various components, and you can form new polyester polymers and effectively get back to the pure polymer. Now, this pure polymer has the same functionality and safety as the original polymer. However, it can be expensive, and really the economics between making polymer from recycled material or from fossil fuels, where it normally comes from, is driven largely by the price of the fossil fuels. But my understanding is that making polymers out of recycled material is never, or to date, is never cheaper than making it from the fossil fuels. But as the fossil fuels get more expensive, the price differential shortens between them. The other challenge with chemical recycling of plastic is that it's difficult to scale, and it's far less common than mechanical recycling. In terms of how paper and board is recycled, paper fiber can be recycled on average about 3 to 5 times. 7 cycles is technically feasible. And the reason why you can only recycle it this many times is that every time you recycle it, the paper fibers, or the fibers within the paper, get shorter and shorter. When it's collected, the paper or board is usually not sorted into food or non-food grades, so it's quite an undefined process. It may be sorted into technical grades. That's the type of board that it is, where it's corrugated, solid board or paper. This material is then mixed with water to form a pulp. The staples, etc., are removed. It's ground. The water is then removed. The fibers are cleaned, maybe bleached or de-inked, and then the entangled fibers, they're the so-called recycled fibers, are mixed with fresh fibers to increase its strength, and it can be processed into the final material. So in terms of our research findings, we carried out interviews in Australia and New Zealand, and concern was expressed within these interviews that despite data clearly highlighting the fact that recycled packaging contains more non-intentionally added substances and more intentionally added substances, and these intentionally added substances are things such as the allowed additives, such as UV stabilizers, that the more you recycle that the material, the higher the concentration of those. So despite the fact that the recycled packaging contains more of these NIASs and IASs than virgin packaging, packaging companies, and this includes the recyclers, the manufacturers, and the suppliers, were not doing enough to explain to the food companies the processes they follow and the checks they employ to ensure the safety of the recycled packaging they manufacture or sell. So this is really the crux of the concern. Really, that the food industry, the brand owners, weren't confident that the products being produced had enough quality assurance around it to ensure their safety. When we spoke to packaging manufacturers, they told us that at the moment they didn't have enough capability to produce the recycled packaging required to meet governmental targets, particularly within Australia. They mentioned that there are more mechanical and chemical processing plants being built to meet this expected demand, but these plants take a while to build, and that for the foreseeable future, recycled polymers will be a small fraction of total polymer production. And this is based on the economics, as I've already discussed. In many cases, it's certainly not cheaper to make packaging out of recycled material compared to petrochemicals. They also mentioned that the current capacity will mean that recycled polymers will be a small fraction of total polymer production, and they have a limited ability to build new plants. It was interesting to understand that in Australia, the government incentives such as tax breaks and regulations are driving the increase in capability in recycled packaging manufacture. Unfortunately, similar enablers and incentives do not appear to exist in New Zealand. When we spoke to the New Zealand brand owners, the level of concern around the use of recycled packaging varied significantly. Sometimes their concern was proportional to the risk associated with the product by being put in recycled packaging, but sometimes it did not. And of course, people's perceptions of risks can vary dramatically. There was a desire by the New Zealand brand owners for packaging companies to clearly demonstrate that they take risk assessment-based approaches that identify risks and establish and monitor critical control points designed to control the identified risks. And some New Zealand brand owners said that the lack of New Zealand specific guidelines or regulations or standards, whatever you like to call them, for recycled packaging was problematic. However, not all brand owners thought this, but many did, and they thought that the development of guidelines, regulations, or standards, and it was mixed on the form that these could take, mixed opinion on the form that these could take. They thought that such mechanisms were required to ensure that critical safety steps in the reduction of recycled packaging were being controlled. So the take-home message from the interviews that when using recycled packaging, it is important that brand owners implement risk assessment-based approaches that can identify the critical packaging parameters and based on this, generate acceptable quality limits, which will probably take the form of product specifications for the packaging material that will then control the identified risk. In terms of what we found out from the literature of the contaminants that can be found in recycled plastics, well, the bottom line is thousands of things can be found and have been found in recycled plastics. These include compounds that originate from flavor or aroma compounds that are present in the material that the packaging contained. These include things such as citrus compounds from drinks. Compounds such as limonene and terpenine seem to survive and be present in the packaging and are difficult to remove. The plastic recycled packaging can contain oligomers. These can be linear or cyclic oligomers, and they originate from the original polymer and breakdown that occurs during its reprocessing. Plastic additives and their degradation products can occur in the recycled packaging at higher concentrations than they do in virgin polymers. As the polymer is recycled, these compounds are added back in to give the new bottle or the new package the desired functionality. These include things such as UV stabilizers and antioxidants, and it's important to understand that over 600 substances are authorized to be used in plastics. Recycled plastic can also contain contaminants derived from non-food grade plastics, for example, bromated flame retardants from electrical or electronic equipment, or they can contain compounds such as 2-methoxynethylene, which is found in fabric conditioner, which, as you all know, is also sold in plastic containers. And then, of course, recycled plastics can contain contaminants derived from consumer misuse, and who knows what that bottle that is found on curbside collection actually contained if it's been spent some time in a consumer's household. And then recycled packaging also contained a whole lot of inorganic elements, cadmium, chromium, nickel, and it wasn't always obvious where these contaminants came from. In terms of contaminants found in recycled paper and board, the main ones of concern are really mineral oil hydrocarbons. These form a significant component of offset printing inks, which are used in food packaging, and they're also found in the glues and adhesives. There's also biphenols that can be found, some phthalates, and diisopropylnaphthalines, DIPN. This is a significant compound of concern, and it occurs in materials such as carbonless copy paper. And there are a whole lot of other compounds could be found, photo initiators, inorganic elements, antimicrobial agents, fungicides, sanitizers, etc. So what risks do these non-intentionally added substances pose to product safety or quality? Well, that depends on the nature of the substance's presence, their concentrations, and their ability to migrate from the recycled packaging into the product. The migration of a substance is dependent on the concentration present, the packaging material type, if it's, e.g., if it's paper or PET or polypropylene or polyethylene, and the properties of this packaging material, its thickness and its porosity. For example, paper and board is relatively porous, where HDPE is more porous than PET, for example. The food product's composition also impacts upon the ability of materials to migrate from the packaging into the food product, and also the potential products to migrate from the food into the packaging material. The physical chemical properties of the food, such as pH, also play a role, as do the conditions under which the product is stored, the temperature that the product is stored at the time that it's stored for, and also the humidity. When it comes to detecting what may be present in recycled packaging, there's two strategies that can be used. These are either targeted analytical methods for the detection of predicted non-intentionally added substances. So if you think that something could be there based on previous studies, then you can go and look for it. Well, more commonly, non-targeted or screening methods are used, and these are designed to detect and analyze a broad range of substances which may differ significantly in their physical or chemical properties. So non-targeted screening is best used when assessing contaminants in the packaging material or looking at the food products and substances that have migrated from the packaging material into the food. The techniques that are used to detect these either intentionally added substances or non-intentionally added substances in packaging or the food, generally techniques such as gas or electrical chromatography. And when you're selecting the best analytical conditions to detect these substances, it's challenging, as extraction methods all have some blind spots, i.e. compounds that they will not detect, will not be extracted, or compounds that will be lost, for example, preparation. Therefore, it's recommended to use a range of extraction and detection techniques when undertaking non-targeted studies. I've talked about this word migration, just wanted to clarify what I mean by this. Many non-intentionally added substances or intentionally added substances have the potential to migrate from the packaging material into the food it contains. Migration is considered to be a four-step process involving diffusion from the packaging material into the air, and then onto the surface of the packaging material, and desorption into the air, then absorption onto the surface of the food product, which can be followed by absorption into the product. And the difference between these stages is shown in this image here. Adsorption is attachment to the surface, and absorption is migration into the product. And as a compound absorbs into a product, then it causes problems because you can't simply remove the contaminant by peeling the fruit, for example. However, it's a complex process which is impacted upon many different intrinsic and extrinsic factors. In terms of once the substance can migrate from the packaging material into the food, then what impact does it have? So what's its potential toxicity? And there's many identified substances, either IAS or NIS, that are present in packaging material. And this is actually packaging material, whether it's been recycled or virgin. And many of these substances can migrate into food. And a lot of them are not substances that are included in the EU list of substances allowed to be used in materials intended to come in contact with food. So people have been looking at what's present in plastics for a long period of time. And even before there was this latest concern around the use of recycled packaging, we knew that there were substances in plastics which could migrate into the food. And some of these substances weren't on the allowed list of substances that are allowed to be used. Substances have been detected in food at concentrations higher than their migration limits. So this is the limits that the EU has set that they're allowed to occur in food. And substances identified in both recycled plastic and recycled board are substances that have been classified as being substances of very high concern. So these are called SVHC substances, and these are things which are substances which are predicted to be either cause birth defects or have been carcinogens, for example. It's important to understand that very few toxicity studies have been carried out on substances that have the potential to migrate from packaging into foods, and very few studies have calculated the daily intake of substances that have the potential to migrate from recycled packaging material into food. So this study, or this field of research, is at very early stages, and there's far more that is unknown than what is known about the risks that these substances actually pose. We're concerned not only looking at the impact of these substances on human health, but also the impact on quality. And our conclusions were really that whether you're using recycled packaging or virgin packaging, you need to follow the same sort of processes. You need to measure the suitability of the packaging for any given application. And when you're doing this, it's important to focus on the relevant parameters. And we consider that these were the mechanical properties of the packaging material, the presence of odors or flavors or taints, and if the packaging material itself had any visual defects, or if it would cause visual defects such as discoloration of the product. In order to look at the impact of recycled packaging on the quality of the product it contains, sensory tests were recommended, as they can be used to detect a wide range of odor or flavor defects in a non-selective manner. And this can be carried out more easily than volatile organic compound analysis using methods such as GC-mass spec. In addition, we're all very used to using sensory-based visual tests such as colour, and these are well-established QA tools. It's important to understand that the New Zealand and to a certain extent the Australian situation may be different to what occurs around the rest of the world. This is because many of our primary products that are exported can be considered to be relatively susceptible to the adverse effects associated with the migration of non-intentionally added substances from packaging. And this is because of their composition. Some have a very high fat content, and fat is particularly good at accumulating and holding odors. We have storage conditions. Some of our products are sent out at ambient conditions. And of course, they're transported in containers in many cases. And if in a container, the material is sealed in there. So if volatile organic compounds migrate from the plastics, they get into the air, there's really nowhere for them to go. They can't dissipate. So it's more likely that they will be absorbed into the food. And of course, our products have long shelf lives. They're frequently shipped around the world. And as cost of shipping increases, there's a tendency to have longer and slower shipping regimes in order to reduce costs. So this problem will only ever get worse. So in summary, the presence of these non-intentionally added substances can impact on product safety. They can cause product taints, that are off flavors or off odors, and they can reduce a product shelf life either directly owing to the migration of compounds into the food from the packaging materials, or indirectly by compounds that have migrated out of the packaging material, accelerating reactions within the food, and these may be chemical or oxidative or enzymatic reactions. Very quick thoughts around the regulations for recycled packaging. If you look around the world, there's a range of approaches that are used. Some countries will set an overall migration limit for contaminants that can migrate out of packaging into food. Other countries require that an impermeable barrier is set between the recycled packaging material and the food. This is normally a layer of virgin plastic. In terms of the recycling processes, especially for mechanical recycling, some regulations state that the plastic input must come from a closed loop where any contamination can be ruled out. So this is something like industrial or post-industrial recycling, where you know and have a chain of custody around the raw material that's going to be recycled, so you know that what it contains, what the potential risks are. If you can't control that, then the recycling process itself must be able to demonstrate in a challenge test that the processes used can reduce contamination to levels that do not pose a risk to human health. Of course, the challenge to this is understanding which compounds to actually test for in either the challenge test and to determine what is actually there. And with regard to that, it's important to appreciate that not all detected non-intentionally added substances in recycled packaging have been identified. So we don't know there's compounds there, but we don't necessarily know what they are. So you get a peak on your GC-mass spec, but you can't identify it. And also, in addition, the origins of many of the non-intentionally added substances that have been detected in either packaged food or in recycled packaging is unknown. In terms of the outputs from the current research, we've produced a summary document, a set of guidelines, and 4 scientific reports. This material can be found at the New Zealand Food Safety Science and Research Centre website. If you click onto our website, you'll see the banner up the top here. Click under resources, and you'll get the drop-down menu will come up, recycling packaging, and you'll get to the page shown here. Within this page, we've included the documents. So we have the first document is the project summary, recycled packaging, definitions, descriptions, challenges and solutions. There's then an article talking about introduction to recycled packaging. There's the guidelines, an article describing the potential impacts of the use of recycled packaging on food quality. Our article will summarise the information we gained from the interviews, so stakeholders' perceptions on the challenges associated with these recycled packaging. And then there's a scientific article that we've actually managed to get published around the risk assessment, identification, migration, toxicity, and consumption of substances associated with recycled packaging. This article was published in Comprehensive Reviews in Food Science and Food Safety. It's an open access journal, and you're able to download that and look at it. On this website, we've also put in 2 other links, a link to suppliers and a link to research providers. At the moment, there's nothing under these 2 headings, but if any companies that supply recycled package are interested in being listed, or really research providers are interested to be listed, please contact me. We're happy to put up under these pages your logo, a 50-word sort of intro to what you do, and of course, a link back to your website. So I want to spend the next few minutes finishing off by talking about the guidelines that were developed for the use of recycled packaging in New Zealand. There were 5 steps under these guidelines. The first step was where you need to build the business case for using recycled packaging, how you can go about assembling the team, and then understanding the technical feasibility of using recycled packaging, how it's implemented, and then it's how to review and improve the process of using recycled packaging. Now, of course, many companies are already using recycled packaging, and many companies who aren't are certainly considering it. So in many cases, building the first 2 stages are probably not necessary if you're already some way down this process. So for that reason, I really today want to focus on step 3, understanding the technical feasibility and the guidelines we put in around this. So this is stage 3. There's 5 or 6 steps under this. The first step is step 3.1, engagement with suppliers of recycled packaging material. And this is where it's important that the food company, the brand owner, goes out and talks to their recycled packaging supplier and really so they can both get understanding of what is needed. When you're going to talk to your recycled supplier, you need to come equipped to answer the questions that they should ask you. And the sort of questions that they should ask you is they should ask you about the product and its proposed storage and use conditions, including its intended use, the type of product that the recycled packaging would be used to contain, the composition of the product, the shelf life, storage conditions, any sort of functional requirements that you may have for your product. You need to understand how it's going to be used within the plant, so the production line capability, the pack size, the number of units needed, and if the packaging will be used for repeat or single-use applications. In addition, the packaging company needs to know from you, the brand owner, the intended markets, and if there's any customer-specific requirements, and indeed how consumers may use the product. So once that sort of information is understood, then the packaging company is better able to advise the brand owner if they are in a position to supply the recycled packaging required. The next step is for the brand owner or the food company to assess the ability of the recycled packaging company to supply contaminant-free recycled packaging consistently. And in this process, important points to consider include the nature of the recycling process that the company supplying the recycled packaging material uses. Do they use mechanical or chemical recycling? The company needs to understand the effectiveness of the different recycling processes and contaminant removal for different materials. PET, it's easier to remove contaminants from PET using mechanical recycling, for example, than it is to remove them from HDPE. The brand owner needs to understand the source of the material that the recycling company uses, whether it's either pre or post-consumer, or it's the same as post-consumer or post-industrial. And of course, post-consumer material has the potential to be contaminated with a wider range of non-intentionated substances than post-industrial or pre-consumer material. It's important that you have an understanding of the controls that the packaging company have in place to ensure that the material they use complies with applicable regulations in key markets. And does the company have a risk assessment-based process in place based on hazard principles, which incorporates critical control points to ensure that it meets these requirements? Other steps that are required, understanding is required, is the steps that the companies take to ensure that the recycled material is not contaminated at some point, either before collection or recycling or during the recycling process. So you need to understand how robust the company's auditing processes are. It's important to understand how the tests that the companies carry out to determine that the recycling process they use removes all possible incidental contaminants and meets regulatory requirements. As I've already mentioned, is this a risk assessment-based process? Is it based on hazard? How was the effectiveness of the recycling process initially validated? And how frequently are tests carried out to verify the safety of the recycling packaging? And also other steps, important questions to ask are, how does the packaging manufacturer or the importer of the packaging material ensure that the integrity of their chain of custody is complete? And how robust are the company's auditing processes? And then the other steps, which I'm not going to go into great detail, are you need to assess the functional suitability of the recycled packaging options that are available, determine the delivery, storage, and responsiveness of recycled packaging suppliers. It's important to understand that much of this recycled packaging comes from overseas, and if you're used to popping down to your local supplier and getting packaging as you need it when you need it, it's important to understand that if you're using recycled material, this may come in only once every 6 months, and it's sort of somewhat a periodic schedule. And then, of course, finally, last but certainly not least, you need to assess the economic feasibility of using recycled packaging. So in conclusion, to protect the New Zealand food industry, food processors and recycled packaging manufacturers and suppliers need to work together to develop a shared understanding of the safety and quality risk associated with each product packaging application, and then together design appropriate safety and quality assurance programs. For the packaging suppliers, such a plan will ideally follow hazard principles and incorporating monitoring and assessment. And for the brand owners, they will pretty much do what brand owners are very used to doing with food products. They'll have food control plans, and the same way that hazards are controlled within food products, hazards also need to be controlled within their packaging material. So they need to identify the risks, and also understand how the packaging, contaminants and packaging may impact upon quality, and ensure that they put in place guidelines that guarantee that they get the packaging at the quality that they require. So that is the end of my presentation, and I'm happy to answer any questions you may have.
Okay, thanks very much, Phil. Yeah, really clear presentation. We do have some time for questions, so I'd like to welcome participants to submit some questions through the Q&A function. There is one there, which I'll start with. Phil, this person had to step out, so they weren't sure if this has already been discussed. I don't think it has. Some customer programs, specifically red meat overseas, don't allow recycled packaging. What is the logic or practicality of packaging companies having separate lines for the various customers? So traditional versus recycled packaging.
So obviously, customer-specific requirements have to be taken very seriously. If the challenge is that in the future, companies are probably unlikely to have the choice whether they invest in using recycled packaging or not. This is a change that is coming, and they'll certainly have to meet particular targets, whether that 25 or 50% of their packaging material have to be recycled. So it may be a case of determining which products to focus on, which products and markets to focus on. The recycled packaging material is used there. There may be a few markets where you simply cannot use recycled components. But across your whole product range, you're going to have to meet those targets at some stage, I believe.
So there's a supplementary question there. Do you think customers would change their stance if there are more regulations in place? I presume this means around ensuring the safety of recycled packaging.
Yes and no. We know that some countries and some companies base their requirements around food safety on criteria other than science or food safety. So you'd like to think that if you put in place the scientific argument that the product is safe, that countries would change, but that is not always the case, of course.
Thank you. Keep those questions rolling in, folks. I've got one, Phil, around product types in New Zealand. You did talk a little bit around this. Are there particular product types that are more at risk or of most concern around recycled packaging and migration of contaminants?
Yeah, so the products with a longer shelf life, products which have a closer contact with the material, products which are stored at ambient temperature, just because there's a greater potential. So if you're putting, tomatoes into a PET clamshell type container, it's on the shelf for 4 days, that the risk profile differs than if you're putting product into a container and shipping it around the world, and it's have a shelf life of 5 to 6 weeks. And of course, a lot of our products are shipped around the world. We do expect longer shelf lives.
Okay, thank you. Question here around sustainability. Can you comment on the sustainability aspect towards considering recycled packaging?
Yeah, this is an area that's still evolving. And I guess that the jury is out at this stage, whether for some polymers and packaging situations, whether it is more sustainable. I guess it's more sustainable. I'm sorry, I'm getting mixed up between economics and sustainability. It's got to be more sustainable. Whether it's more economically viable is the question. So it will come with additional cost in order to get that sustainability. The other critical question is it feasible at the moment? Do we have the capacity? And the answer is probably no as well.
Thank you. Okay, we've got a few coming in now, Phil. So is the future development of biodegradable/compostable packaging materials that meet the packaging needs rather than trying to recycle PET, etc.? What's your opinion on that?
My understanding is that the biocompostable products can only meet a certain proportion of the packaging needs. There's products that this is not suitable for, and there's markets that this is not suitable for, and also our capacity to build this, to make such products is also limited. So they certainly have their place, but we'll be using plastics, fossil fuel-based plastics or recycled plastics for many years to come, I would argue.
Thanks, Phil. Next question is, what's known about consumer willingness to lower their expectations about having contaminants in their food or reduced quality from off flavours as a possible consequence from buying products packed in recycled packaging?
I don't think that's been studied, but I'm pretty confident that consumers will not be willing to lower their expectations around quality or safety.
Okay, we've got another one here. My understanding is that chemical recycling is more or less a fantasy given current economic constraints. However, is the incidence of non-intentionally additive substances significantly lower after chemical recycling compared to mechanical?
Yes, it is. Chemical recycling is considered to produce polymers that are identical to the virgin polymers in terms of safety and quality. Yeah.
Okay, excellent. Do you believe these safety issues will potentially pose problems in respect to what recyclable declarations can be made to customers on packs, either on products with virgin materials versus recycled? If so, how do you manage this complexity?
So if we don't act and there's a food scare or worse, a food incident associated with recycled packaging and food contaminants, then this could be a problem. But I see this, the way forward is to put in, robust procedures, hazard-based procedures to ensure that this doesn't happen. We know for many of the raw materials, foods that we produce, there's hazards, and the food industry puts in place to control these hazards. So I think food packaging has to be treated the same way, understand that there are hazards, and put in suitable control regimes. And so, build safety into the system hopefully that's what's happening now.
Thank you. We'll take one more question. It's great to see a number of different sectors represented here. Do you feel regulators and governments or even consumers are pushing for change to understand the risks and are looking to do the work to make this safer?
Well, I don't think consumers are thinking about the risk associated with recycled packaging. They're more concerned about the environmental impact of packaging. So they want something done about packaging, and recycling appears to be a way to do that. Certainly regulators around the world are, and of course different countries have different expectations, but certainly in many parts of the world this is a very hot topic, and I think the regulations around contaminants will only ever get tighter and tighter.
And domestically, Phil, with New Zealand regulators?
This doesn't seem to be top of the agenda or top of mind for New Zealand regulators at the moment.
Okay. All right, I see we're just ticking over 10 to 11, so we'll just look to wrap this up. I'd like to thank everyone who's participated, to come along and see Phil today, and also extend a big thanks to Phil for giving this presentation. I know it's a summary of a huge amount of work that's gone in behind the scenes over a long period of time. So thank you very much, everybody. Hope you have a great day. This presentation will be made available on the Food Safety Centre website in due course. Thank you.
Thank you.